Hi, here to talk about Chapter 7, Section 2, the property of powers. And I wrote out the names if you're going to work ahead while I'm doing this top part. I really don't care if you know the names. I maybe should, but you're never going to be asked in my class to know them. But being able to apply these properties and do these things with exponents, vital to your success. So first thing, kind of like the last section, you just want to make sure we're all kind of on the same page. If you have something, here's a b for the base of the exponent. If you have that b squared, that's saying b times b. If you have a b to the third, similar, but now we have three b's, so b times b times b, which now we're going to start using variables for the exponent. If you have a b to the n, that's saying b times b times b times dot dot dot, times b, and you're going to have n of those b's, or maybe I'll say n times. But that's going to be this first part. That's what the exponents are doing. Okay, so now this product of powers. Product is multiplication. So what this is trying to say is if you have a b to the m times a b to the n, you have the same base, so it has to be like 2 to the 7th times 2 to the 14th or whatever. That the base has to be the same number in both cases in order to combine them. So the question now is, what do we do with the m and the n? If you ever draw a blank on these, one thing you can do is just try it kind of off on the side. Let's say we have b to the third times b squared. If you pick smaller numbers, then you can say, well, b to the third, that's b times b times b. And then that whole thing is times b squared, which is b times b. Well, if you look, this is the same as b to the 1, 2, 3, 4, 5, b to the 5th. So what do you do to the 3 and the 2 to get 5? You add them. So it's going to be the same thing here. B to the m times b to the n we take, and our exponent is going to be m plus n. We take and add those two together. Now if we have the power of a power, so we have something like b to the m, a power, and we're going to take that to the nth power. You have the power of a power. Now what do we do with the m and the n? It's going to be b to what? Well, try it again. If you have a b to the third squared, well, that's saying b to the third times itself. So b to the third times b to the third, which then is b times b times b, b to the third, times another b times b times b. So now here I have 6 b's, so we have to multiply the 3 and the 2 to get 6. So in this case, with the m and the n, it's b to the m times n power, or b to the mn. Quotient of powers, quotient's division. So now it's saying, what if we have b to the m over b to the n? Now that's going to be b to what power? You could try to do process of elimination. We added, we multiplied, what's going to be next? Or, try it. If you have a b to the third over b squared, we have a b times b times b over b times b. And now we can cancel things out. We can cancel this b in the numerator with that b in the denominator. Cancel this b with that b, so we're left with a b to the first. So the 3 and the 2, we have to subtract them to get a 1. So in this case, it'd be b to the m minus n. Now some people are great at just rote memorization, just memorizing things. I always struggled unless I could make sense of it. So here's kind of how I took this and came up with a way that, well, how can I keep this straight in my head? So this is what I did back in middle school. I'll try to squeeze it in on this page. If you try to think of what are the math operations that typically the answer is going to be larger than the numbers you started with. And we're not looking at including zeros and negatives and crazy things like that. But if you would think, you have your addition, tends to make things bigger. I wouldn't write this quite yet, but addition, multiplication, and exponents. Well, if you're looking at, well, what's the strongest one? And which one's, like, say you have the 3 and the 2 again. 3 plus 2 gives you 5. 3 times 2 gives you 6. And 3 squared gives you 9. So the exponent's going to be the strongest. So the way I found that I could memorize this is this. That if you take and put those in order from strongest to weakest, you have exponent, you have multiplication, and you have addition. And you always do one step lower with the exponent. So here would be my first example, that I have a power to a power. So I start out here this exponent. What do you do to those exponents? You multiply them. You have m times n. It works then if you have multiplication. If you have something to a power times something to a power, if you're multiplying them, well, you do one step lower with the exponents. Always do one step lower, maybe I should be saying weaker, with the exponents. One other place where this kind of comes in handy, it doesn't really fit one of the properties in this section, but sometimes people have like a b to the m plus b to the n. And they'll try to combine those in various ways. Well, if you do this, it's addition. You always do one step lower with the exponent. There's really nothing there, that you can't combine those. And if you really stop and think about it, that's kind of like where you have like a x squared, maybe plus 2x. That when you see it like that, you can't say like 3x to the third or 3x squared. You just can't combine them. So, okay. With this bottom one here, you could do the same sort of thing instead of making your answers larger with making your answers smaller. And when you do that, you're going to have, it ends up being roots. It kind of be the equivalent to exponents. But then division is more powerful than subtraction. So if you're always doing one step lower with the exponents, if you're doing division, if you're dividing things with exponents, you do one step lower, you subtract with the exponent. Alright, the last three things in here are going to be starting with power of a product, and again, write the titles, don't write the titles. But my example for this, where am I? So power of a product. So if we have a product, something with multiplication, so if we have a times b all to the m power, the m applies to everything in the parentheses. And that's a real common thing that people make mistakes in my class, that they'll just say that, oh, that's a times b to the m without the parentheses. But instead it's a to the m times a b to the m. Now if that had been addition, that doesn't work. So if you have an a plus b to the m, you can't say that's a to the m plus b to the m. That doesn't work. That's where you have to get into FOILing, and yeah, it gets crazy. All right, power of a quotient. So quotient is division. So we have a divided by b to the m. And that's the same sort of thing. If it was a minus b, you wouldn't distribute the exponent, but when it's division, you do. So you have a to the m divided by b to the m. And you can kind of visually look at it as though the m applies to both in both of those. So the m goes to both things. All right, the last thing is this zero exponent. What they're saying there is if you have a base to the 0 power, what's that going to equal? When in doubt, try it on your calculator. 5 to the 0, 10 to the 0, pi to the 0. That's going to equal 1. As long as the base, if you do 0 to the 0, you get an error. So I'm going to say b to the 0 equals 1 if b does not equal 0. And that's officially what you could say is the end of the notes, but with this one I kind of like to look at why, so it's not really smoke and mirrors. If you were to take some number, I'm just going to pick 5, but this will work for any number except for 0. If you do 5 divided by 5, well, we know that that equals 1. If you take and look at that though and say, well, 5 over 5, that's the same as 5 to the first over 5 to the first, you can say, well, hey, I have the same base, I could subtract my exponents. Well, then that's going to be the same as 5 to the 1 minus 1, which is really the same as, oops, switched over to b's again, 5 to the 0, because 1 minus 1 is 0. So 5 to the 0 then has to equal 1. And the reason they have this base can't be 0 is you can't go through and do that with 0 over 0. You could do it with any other number, or pi over pi, or 14 over 14. But as soon as you get 0 over 0, you can't say this equals 1 because you're not allowed to divide by 0. That's all I have to say about section 2.